In lesson 9.3, we're really reviewing a concept that you learned in geometry. We're going to write equations of circles. So the standard equation of the circle with the center at 0, 0 and the radius r would be x squared plus y squared equals r squared. And then r is the radius, not r squared. And I would pause the video if I were you and write this down in your notes. Okay, so our first example is asking us to graph this following equation, and you'll notice that it's not in standard form. It's not matching the equation that I just wrote down. So the first thing we're going to need to do is to move the x squared over. So we end up getting x squared plus y squared equals 36. If this is r squared, then we need to take the square root of 36. So we know that r is going to be equal to 6, and that's the radius. So we're going to go over to the graph and put a point at all our distances from the origin, 6 units, and then we can just draw our circle. So from the center to any point on the circle, that's our radius, and it should come out to be equal to 6. Our next example is not quite in standard form. We have coefficients in front of our x squared and y squared. So the first thing we're going to need to do is to factor out or divide everything by 4. So when we do that, we end up getting x squared plus y squared equals 32. And remember I said we divided everything by 4. 32 is not a perfect square. So we're going to we know that we need to take the square root of 32. That's the same thing as 16 times 2. The square root of 16 is 4. So our radius is 4 square root 2 because it started off as r squared equals 32, and then we square root. So anyway, 4 square root 2. If you put that into your calculator, it comes out to approximately equal to 5.657. So you're going to go to the graph and estimate about where those points are. So you're going to plot your 4 points in each quadrant, 1 in each quadrant. Okay, so we plotted our 5.657-ish point. 4 places. It's not really in a quadrant, it's on the x and y axis, and we drew our circle. All right, so we're already in the home stretch. This is our last slide. This one says, and you'll have these questions in your homework, write the standard form of the equation of the circle with the given radius and whose center is the origin. So if our radius is square root 13, we know that the standard form is x squared plus y squared equals r squared. So if I square the square root of 13, the exponent cancels out the radical, so it equals 13. So our equation is going to be x squared plus y squared equals 13. All right, in our final example, it says that we are given a point, and we're still at a center that is at the origin. So our given point is 2, -5, so we're going to go over to our graph, go over to down 5, and plot our point. And then remember, when we did this before, we went over and down or up 4 different places to draw a circle. So let me just kind of draw a circle. It's not going to be perfect, but let me just say the circle looks kind of like that. And our center was the origin. So from the origin to the side of the circle, we know that that's the radius. So now we need to find the distance from 0, 0 to 2, -5. If we think back to a previous lesson, we're going to use the distance formula. Okay, I did a couple of things. I am reminding you what the distance formula looks like. I have my group 1 and my group 2. I subbed in the points, and then I changed the distance. I'm just going to call it the radius because that's what we're really finding, the distance of the radius. So now we'll finish it up. R equals, we have 2 squared plus -5 squared. So R equals 4 plus 25. R equals the square root of 29. And then you can go ahead and write your equation from there.